Welcome to Trigonometry and Area. I'm Mr. Pi, the math guy. What we're going to be doing in this lesson is using the trig functions sine, cosine, and tangent to help us find the length of the apothem or other lengths that are necessary when finding the area of regular polygons and triangles and other different shapes. So let's get this geometry party started. In example 1, we are asked to find the area of a regular polygon with 10 sides and a side length of 12 centimeters. Well, to find this area, we need to use the area formula for a regular polygon, which is 1/2 the length of the apothem times the perimeter. Well, the perimeter is real easy. The perimeter is going to be 12 centimeters times 10 sides, which is going to be equal to 120. And that would be centimeters. So we know the perimeter. Now we have to calculate the apothem. And here's how we do that. To calculate the apothem, if we take a look at our diagram over here, we have the two radii and the apothem drawn in. And to find the length of the apothem in this case, we're going to use this idea of angle 1. And we know the length of AM, the side of the regular polygon, is 12. And since this apothem acts as the angle bisector, it also bisects this side down here. So we know the length of XM is 6. So if we consider angle 1, that would be opposite side over the adjacent side. So to find the length of the apothem, we're going to use the tangent ratio. So we have to calculate the number of degrees in angle 1. And this bigger angle, angle ACM, has 36 degrees in it. And the measure of angle ACM has 36 degrees in it, and I get that because I take 360 degrees in this polygon and I divide it by 10, the number of angles all the way around, and that would give us 36 degrees in this isosceles triangle, and this angle 1 is equal to 1/2 of that mess right here, 36 degrees. So we take 36 and divide it in half to get 18 degrees. So the measure of angle 1 is 18 degrees. So to find the length of the apothem, it's going to be the tangent of 18 degrees being equal to the side opposite over the side adjacent, 6 over A. To solve this, we're going to multiply both sides by A over the tangent of 18. When I multiply this side by A over this tangent of 18, the tangents divide out, the tangent of 18 degrees being equal to, and then on this side the a's divide out, and it leaves 6 divided by the tangent of 18 degrees. So now I can substitute that in to here. So the area is equal to 1/2 times 6 over the tangent of 18 degrees times the perimeter, which is 120 centimeters. When I run that into the calculator, which I'm going to show you how to do here momentarily, you find that the final answer is going to be approximately 1,110 square centimeters. In example 2, we're told the radius of a garden in the shape of a regular pentagon is 18 feet. Find the area of the garden. Well, to find the area of the garden, we're going to have to use the area is equal to 1/2 the length of the apothem times the perimeter. Now, this is a much more involved problem because we have to find both an expression with a trig function for the apothem and an expression with a trig function for the perimeter. So let's start by finding something for the apothem. And the apothem in this case is given by A. And if we look at this right triangle, triangle ACX, and this angle theta, the apothem is the adjacent side over the hypotenuse. So that's going to be the cosine. So that's going to be cosine of theta is equal to the apothem over 18. So when we solve this thing by multiplying each side by 18, and I like to switch it around too, we find that A, the length of the apothem, is equal to 18 times the cosine of theta. We're going to calculate theta in a minute. Now, for the perimeter, what you have to realize for the perimeter is that we can calculate this length I have labeled b by using the sine function. The sine of theta is equal to b over 18. But that's only one part of this. To get the length of AB, or this side, it's going to be 2 times b. And then we have to multiply that by 5 to get the entire perimeter. So whatever we get, we're going to multiply by 5. So it's going to be this. So we'll get to that in a minute. To work with the perimeter, we need to find b. And like I said, the sine of the angle theta is going to be equal to b over 18. Again, we multiply this by 18 on both sides, and we get b being equal to 18 times the sine of theta. And again, we'll calculate theta in a minute. Now that we have this figured out, the length of b, if you will, we have to multiply it by 2. So 2b is going to be equal to 2 times 18 times the sine of theta. Finally, this is the length of one side. We have to multiply that by 5. So we're going to have 5 times 2 times 18 times the sine of theta. Now, let's calculate the sine of theta. This should be a pretty easy thing to do, or not the sine of theta, but the measure of angle theta. Inside of here, what you have to realize is the measure of angle theta is going to be 1/2 the angle that I just showed here, the measure of angle ACB. Theta is going to be 1/2 of that measure. And the measure of angle ACB is equal to 360 divided by 5. And the reason that's true is because there are 5 congruent central angles inside this regular pentagon. And each one of them, since they're congruent, will have the same measure. So if we take 360 and divide it by 5, that gives us 72 degrees. And remember, the measure of angle theta is equal to 1/2 of that. So 1/2 of 72 degrees is 36 degrees. So anywhere we see the measure of angle theta or theta, we can put in 36 degrees. So let's see how we take this mess and put it into our formula. Let me gather this stuff up and let me just move it a little bit so I have a little more room to work with. So, substituting this information into our formula, 1/2, the length of the apothem, which is 18 cosine, and that'd be of 36 degrees, times what I have down here in blue, 5 times 2 times 18 times the sine of 36 degrees. 5 times 2 is 10, and 10 times 18 is 180, so that's going to be 180 times the sine of 36 degrees. I need to move this stuff a little bit more. Let me get this over here, and let me just put all that together. Make it a little bit smaller to give myself some more room. And really what you're going to find is from here, it's a matter of plugging it into the calculator. And when we plug all that into the calculator, what it ends up being, 770, and that would be 70 feet squared, square feet. So the area of this garden is about 770 square feet. And it really boiled down to finding an expression for the apothem with the cosine and one for the perimeter with the sine. What I'm going to show you how to do here is how to enter 1/2 times 18 times the cosine of 36 degrees times 180 times the sine of 36 degrees into a TI-84 graphing calculator. Remember, we are entering 1/2 times 18 times the cosine of 36 degrees times 180 times the sine of 36 degrees. So 1/2 will enter as 0.5 times the cosine. Well, actually, we need to put in there times 18 times the cosine of 36 degrees. And we need to multiply that by 180 times the sine of 36 degrees. And we can see you have it entered. It's so long it does go off the screen. And then you simply press enter, and it gives an answer. This would be in feet, 770 feet. Even if we rounded that, that'd be about 770 feet. So they're entering a fairly complicated sine and cosine function into the calculator. Here we have a theorem the area of a triangle given side, angle, side. The area of a triangle is 1/2 the product of the length of the two sides and the sine of the included angle. For this diagram down here, we have the area of triangle ABC is equal to 1/2 the length of B times the length of C times the sine of angle A. We're going to see how to use this in our upcoming example. In example 3, we're told a triangular park has two sides that measure 200 feet and 300 feet and form a 65-degree angle. Find the area of the park to the nearest 100 square feet. So again, we're going to be rounding this, and notice it's not hundredths, it's 100 square feet. So it's going to be a place value greater than 1. Here I have that little formula we just discussed. The area is equal to 1/2 the length of the given leg times the length of the other given leg times the sine of the included angle. So for this particular problem, it really just turns out to be kind of a plug and chug kind of problem where we plug in the numbers and chug through the calculations. So we have 1/2 times 200 feet times 300 feet times the sine of 65 degrees. This amounts to a calculator problem. When you enter this into your calculator, it comes out to be a decimal number 27,189.234, and that's rounded. And we're asked to round to the nearest hundreds place. So that'd be this ones place right here, not ones place, but the hundreds place. There's a 1 in it, and the 8 tells us to round that up to a 2, so that'd be 27,200, and that would be square feet. So there. If you know the measure of the included side of two sides of a triangle, you can easily use the sine function to find the area of that triangle. I'm going to show you how to enter 1/2 times 200 times 300 times the sine of 65 into a TI-84 Plus graphing calculator. To enter this expression into the TI-84, you're going to enter it as 0.5. That's 1/2 times 200 times 300 times, now here comes the critical part, the sine, right here, the sine of 65 degrees. And you simply hit enter, and you can see the result right there. The result's 27,189.2. In the problem you're asked to solve, you're asked to round to the nearest hundreds, so that'd be 27,200.